Hello there students, welcome to another video of our vector series. In today's video, we'll be covering the triple scalar product. As you can see over here, we've got a parallel piped shape which is made up of three vectors being vector B, C and vector A. We also have the cross product of vector B and C, meaning that this vector over here is perpendicular to both vector B and vector C. Alright, we will now try to solve for the volume of this shape. As we know, volume is given by length times breadth times height. And the area can be given by length times breadth. Substituting the area into this formula, we realize that the volume can also be expressed as the area times by the height. I'll just shift this over here to make space. As we can see, the area is given by the length times by the breadth. And if we want to find the area of the shaded area, or the area that is made up of vector B being the length and vector C being the breadth, we realize that the product of these two vectors can also be expressed as the magnitude of the cross product of vector B and vector C. And so we have now found the area. Looking at our diagram, we see that there's a triangle that we can extrapolate that is made up of the side being H, another side, the hypotenuse being the vector A, and an angle in between them. And so if I extrapolate this triangle over here, where vector A will express it as the magnitude of vector A and H, and then theta will be the angle between them. Using SOHCAHTOA or using cos theta, where the adjacent side, which is H, over the hypotenuse, which would be the magnitude of vector A, is equal to cos theta. And solving for H, or multiplying both sides by the magnitude of vector A, realize that cos theta multiplied by the magnitude of vector A will give us our H. And so we have now solved for the area and the height, meaning that we can substitute these two into our formula over here to find the volume of the shape. So the area is the magnitude of the cross product of vector B and C multiplied by the magnitude of A multiplied by cos of theta, which is the angle between vectors. In the previous video, we realized that the dot product of two vectors, which in this case is vector A and vector B, is equal to the magnitude of the first vector multiplied by the magnitude of the second vector multiplied by cos theta. Remember that the cross product of two vectors produces a third vector, meaning that the cross product of B and C is a vector on its own, as illustrated in the diagram. And so we can see that the dot product of two vectors equals the magnitude of the first vector multiplied by the magnitude of the second vector multiplied by cos theta. And if we treat the magnitude of the cross product of B and C as a vector, we'll have the magnitude of the first vector and the magnitude of a second vector multiplied by cos theta. And that's what we have here, where we have the magnitude of the first vector and the magnitude of the second vector multiplied by cos theta. We now can see that we can express the volume as the dot product of two vectors. The first vector being the cross product of B and C, as we can see, and the second vector being vector A. One of the properties that we've covered for cross product is that the dot product is distributive, meaning that you don't always have to calculate the cross product of B and C. You can also represent this in this way, meaning that you don't always have to find the cross product of vector B and C. You can also find the cross product of vector A and C. You can find the cross product of vector A and C with the dot product of B. Thank you for watching this video. Make sure to follow, like, and subscribe.